Good morning students, welcome to Sri Guru online classes. In the last lecture we discussed the numericals and today also the continuation of NCERT numericals. Today let us discuss the numericals number 4. The monochromatic light of wavelength 632.8 nanometer is produced by a helium neon laser. The power emitted is 9.42 milliwatt. We should find these three. Find the energy and momentum of each photon in the light beam. Second one, how many photons per second on the average arrive at a target irradiated by this beam. Irradiated by this beam. Here we should assume that the beam to have uniform cross section is less than the target area. Here they mention we should assume that, what we should assume? The beam to have uniform cross section area which is less than the target. On that particular target is uniform cross sectional area is less than that target, we should assume. Now come to the third one. How fast does a hydrogen atom have to travel in order to have the same momentum as that of the photon? We should find the velocity of that hydrogen atom in order to that the same momentum as that of the photon. The same like a photon, it is also traveling. We should find that. First is find the energy and momentum, then the number of photons emitted per second we should find, and third one is the velocity we should find by same amount of momentum. Already we know that the expression for energy and momentum and also the number of photon acting per unit area of cross sections, and also we know that the velocity formula. Let us see one by one. What are the things are given? Write yourself first neatly. Given the wavelength they mentioned, lambda which is equal to 632.8 nanometer. Nano we should write in terms of 632.8 into 10 raised to minus 9 meter. This is our wavelength. Then they mention the power of that emitted helium neon laser, power which is equal to P capital P which is equal to 9.42 milli means 10 raised to minus 3 watt. Then they mention the H value as well as 6.63 into 10 raised to minus 34 joule second, and one atomic mass unit of that hydrogen is 1.66 into 10 raised to minus 27 kg. Just we convert all the given values in terms of SI unit, and we require the charge of electron also, that is 1.6 into 10 raised to minus 19 coulomb. Okay, this is about the given values. First we should find the energy. First one is energy. What is the formula for energy? Energy is equal to energy of a photon. Already we know that, we studied in the characteristics also, energy of photon h nu. We can also write Sc by lambda. This is just a conversion. Nu we can write C by lambda. Nu we can write C by lambda. What is C? C is velocity of light, that is C is equal to 3 into 10 to the power of 8 meter per second. Okay, now just substitute the values. H means Planck constants, that is 6.63 into 10 raised to minus 34, and C value is 3 into 10 to the power 8 divided by lambda is, what is the wavelength? 632.8 nano means 10 raised to minus 9 meter. Listen here, joule second, here is meter per second, and here is, what is the value for in terms of meter? Meter get cancels, and that converting the joule second in terms of energy, that is energy in terms of joule, or you write to yourself, this is joule second. If you want to clear means, this is joule second, listen here, this is joule second, and this is meter per second. This second get cancels, here is our meter get cancels, remains is joules. The energy unit is joules. Now calculate yourself, just convert the powers, just take the 10 raised to minus 9 to the numerator, it becomes plus 9 plus 8 is nothing but plus 17, minus 34 plus 17 means around minus 17. You just multiply 6.63 into 3 and divide the values, and final energy is 3.14 into 10 raised to minus 19 joule. 3.14 into 10 raised to minus 19 joule. Just to calculate yourself, just multiply the numerator and divide the values. Finally we are getting this much of energy, that is 3.14 into 10 raised to minus 19 joule. In that A bit only we should find the momentum also. What is momentum? Momentum is equal to mass into velocity. We don't know the velocity, and also we know the mass of that hydrogen atom, but it is not possible to find the hydrogen atom. Why? Because it is helium neon laser. Just you convert, momentum is equal to, we know that the formula, h by lambda. Momentum is equal to h by lambda. How we got this? If you don't know this also, how to find the momentum means, according to Einstein formula, E is equal to mc square. Now write yourself, E is equal to mc into c. mc means momentum, E which is equal to, this is nothing but a momentum p into c. Momentum p which is equal to E by c. You just use this one. After converting that, use that one. How to convert this momentum? Momentum p which is equal to, what is E? E is equal to h nu, or sc by lambda. Sc, and this denominator c as it is, and you write the lambda. sc by lambda is nothing but E. Now just you cancel cc, again we are getting h by lambda. Already we explained in the theory bit. What is the formula for momentum now? Momentum is equal to h by lambda. We know the value of h, that is 6.63 into 10 raised to minus 34 joule second, and denominator lambda is, wavelength is 632.8 nano means, that is 10 raised to minus 9. Just convert the power values and divide the numerator and denominator. Ultimate our answer is 1.05 into 10 raised to minus 27. Momentum is mass into velocity. Mass is kg, velocity means meter per second. The SI unit in all the branches of physics we are considering same. It is not going to change. 1.05 into 10 raised to minus 27 kg per meter per second. This is our momentum. We got momentum and energy, and this is over. Now come to the second one. How many photons per second on the average arrive at a target irradiated by this beam. Arrive at a target irradiated. Irradiate means emitted from that particular area of cross section. From a particular area of cross section, the one photon is emitting one electrons, another photon is emitting another electrons from this particular cross sectional area. This cross sectional area is to remove the electrons. That already we know that the formula, the number of emitted photons we can find by power by energy formula. This we know that already, power by energy. Energy means h nu. Particular frequency, this much of power we required for that particular metal surface. Now what is power? Already they mentioned the power values, that is 9.42 into 10 to the power 3. Denominator is energy h nu. Already we got the answer. How much? That is 3.14 into 10 raised to minus 19. Just to convert photons per second. Photons per second. What is the answer? You just calculate yourself. What is the answer? Answer is 3 into 10 to the power 16 photon per second. 3.0 into 10 to the power 16 photons per second. Now come to the third one. How fast does the hydrogen atom have to travel in order to have the same momentum? It is not change in momentum. Momentum must be same. How fast it is going to move? How fast does the hydrogen atom have to move in order to have the same momentum as that of the photon? Photon momentum is not going to change. With the help of same momentum only, how fast does that hydrogen atom is to travel? Hydrogen atom mass, we know that mass of hydrogen is, that is 1.66 into 10 raised to minus 27 kg. How we are going to find the velocity? Means momentum which is equal to mass into velocity. Mass into velocity. Now velocity which is equal to momentum by mass. We are not changing the momentum. What is the momentum now? Momentum is equal to 1.05 into 10 raised to minus 27 by, what is mass? Mass is 1.66 into 10 raised to minus 27 kg. Here is momentum is equal to, that is kg meter per second, and mass is kg. Now kg get cancels. The velocity unit is v is equal to, just divide minus 27 get cancels around, that is 0.63 meter per second. 0.63 meter per second. It is going to cancel. Now divide it. The final answer is this much. These type of questions they are going to ask in 5 marks bit. Keep in your mind, this is the very important questions. That's why I am going to explain in detail. Okay. Now come to the next question. Now down. Okay, next question is, next one, question number 5. I am solving NCERT numericals only. Why? Because they are going to ask NCERT numericals only. Okay. It is not same as it is but they are going to change the values. Methods are same to solve the particular type of numericals. Okay, next one is this is also very important. Calculate the change in stopping potential. Calculate the change in stopping potential. Change in stopping potential for photoelectrons emitted from a surface if the wavelength of the incident radiation or light, incident light is reduced from 5,900 angstrom to 5,000 angstrom. Already we know that 1 angstrom is 10⁻⁻10 meter. Calculate the change in stopping potential for a photoelectrons emitted from a surface if the wavelength of the incident light is reduced from, initially it is 5,900, it is reduced to 5,000 angstrom. If the intensity of incident radiation decreases, the current also decreases, but here is the wavelength of incident radiation is decreases. Wavelength, how the wavelength is related to the incident radiation and stopping potential. Just to keep in your mind how the stopping potential and wavelength are related. From the Einstein equation we know that, what is our Einstein equation? Einstein equation is half m velocity maximum square, which is equal to h nu minus phi naught. H nu minus phi naught. Phi naught is our work function. Now come to one of the important relation I already explained in the last class. Before going to solve the numericals, I explained the different expressions. In that, the kinetic energy or energy is always proportional to or always equal to stopping potential, that is stopping potential V naught. Keep in your mind, if the stopping potential is not equal to, or that energy is not equal to stopping potential, means it is not possible to eject the electron from the surface. If the energy is equal to stopping potential, then only it is possible to emission of electron from the surface of a metals. Now here is, we should convert that kinetic energy in the form of E V naught. Already we know that in the printed notes also I mentioned half mv square is equal to E V naught. This is the expression E V naught. That E V naught is our potential. Potential means the energy. Here energy means kinetic energy. E V naught. Instead of considering V naught, just I am considering as a stopping potential S. Vs means stopping potential. It becomes h nu minus phi naught. H nu minus phi naught. Here is the wavelength of incident light is reduced from 5900 to 5000 angstroms, but we should convert in terms of energy. Just to consider this work function this side, E Vs plus phi naught, which is equal to h nu. Shall we write like this? E Vs plus phi naught, which is equal to Sc by lambda naught or lambda. Why? Because frequency nu, which is equal to C by lambda. This is our expression. From this expression only we should find the change in potential or change in stopping potential for a photoelectrons emitted from the surface. If the wavelength is reduced from 5900 angstrom to 5000 angstrom. Now that is our expression. Now I am considering here is the two wavelength, that's why lambda 1 lambda 2. The first relation shall I consider like this? E Vs1, this is the first stopping potential, plus work function is remain same for same metal surface, which is equal to h nu or Sc by lambda 1. For second stopping potential, that is Vs2, the work function is remain same for a metal surface, it is Sc by lambda 2. This is initial wavelength and this is our final wavelength. From this to this it is going to reduce. Just to compare yourself, these two, just to compare yourself, or subtract equation 1 and 2. Subtract equation 1 and 2. Equation 1 and 2, just to subtract, and these stopping potential are going to cancel. Why? Because same stopping potential for the same substance, these are going to cancel. It becomes EVS1 minus EVS2, stopping potential of 1, stopping potential of 2, which is equal to Sc by lambda 1 minus Sc by lambda 2. Now E is say common for this, stopping potential 1 minus stopping potential 2. Why we are considering like this in the form of difference means we should calculate the change in means difference forms. What is the change in stopping potential, which is equal to, here is common is Sc, 1 by lambda 1 minus 1 by lambda 2. Now just take this E that side, Vs1 minus Vs2, which is equal to Sc by E into 1 by lambda 1 minus 1 by lambda 2. Now here stopping potential is the difference in the stopping potential Vs1 minus Vs2, which is equal to, what is the value of H? That is 6.63 into 10 raised to minus 34 joule second into C means 3 into 10 to the power 8 meter per second, and denominator E value is 1.6 into 10 raised to minus 19. Now in the bracket you write the wavelength, that is 1 by lambda 1. Lambda 1 means 5000 angstrom. 5000 angstrom. 5000 angstrom. 5000 angstrom means that is 10 raised to minus 10 minus 1 by lambda 2. Lambda 2 means from 5900 to it is going to reduce. This is the higher wavelength, that is 5900 angstrom. That is, angstrom means you just write directly, that is minus 10. Okay, now write here. Change in stopping potential Vs1 minus Vs2 is, just to calculate yourself, or you just to take that 10 raised to minus 10 this side, or you better write once again. Here if you want to cancel, you cancel it, or finally you from the calculator you also calculate these the values. Just to take this 10 raised to minus 10, it is very easy to solve. That is 10 raised to minus 10 common is, that is 10 raised to minus 10 take outside. Now it becomes 10 raised to minus 29, take to the numerators, that is 10 raised to plus 29 plus 8 means, that is 37 plus 37 plus 37 minus 34 means, that is plus 3. You just write yourself 6.63 into 3 into 10 to the power 3, denominator is 1.6. Now the LCM is 5000 into 5900, and you just to cross multiply 5900 minus 5000. Now the calculate yourself, the final answer is change in stopping potential, change in stopping potential Vs1 minus Vs2, which is equal to 0.378 volt. Just to calculate yourself, multiply and divide it, 6.63 around 18 or 19, nearly 20 divided by 1.6, and here is 9000 is numerator, and multiply these values and divide it. The power things are going to cancel. The final answer for change in potential is, that is our answer. Okay, note down. Next one. Now next is, that is, the energy of flux of sunlight reaching the surface of earth is 1.388 into 10 to the power of 3 watt per meter square. How many photons nearly per square meter are incident on the earth per second? Assume that the photons in the sunlight have an average wavelength 550 nanometers. 550 nanometers. Listen here, we should find the number of photons emitted per second. But here they mention number of photons per meter square second. We should find number of photons. Watt is our energy, that much of photons emitted per meter square. Why? Because this is the square meter. They are asked in terms of square meter. Per square meter per second. We should find the per square meter per second. We should find the emission of photons liberating by this much of watt. Let us just to consider this is a square. Here is sunlight is reaching a particular surface. On that particular square, how many photons is incident per second? How many photons is incident per seconds? What is the given values? What is the given value? The energy of photons, energy E, which is equal to 1.388 into 10 to the power 3 watt per meter square. And one more is the average wavelength lambda, which is equal to how much? That is 550 nanometer. Already we know that the relation. What is that relation? Number of photons emitted, a certain power is with respect to certain energy. That power is nothing but we can write. How to write in terms of power? Power is, how we can write power? Just keep in your mind, E, they mentioned the energy of flux of sunlight is reaching the surface of earth is this much. Then how to write the power values means, just keep power as it is. Energy we can write the energy in terms of power they mentioned. What is the P value? Sorry, here they mentioned the power value, P value only. The energy of flux of sunlight reaching the surface of the earth is 1.388 into 10 to the power of 3 watt per meter square. This much of square area, this much of power which is going to incident some photon from that particular square area. This is power is 1.388 into 10 to the power of 3 watt per meter square, and this is the wavelength. Our formula is N is equal to power by particular energy. We can write N is equal to power is P as it is, energy is h nu. Shall we write like this? P by h, nu means C by lambda. Shall I write lambda to the numerator, or you write C by lambda? Shall I write this lambda to the numerator? P lambda by hc. We know that the power value 1.388 into 10 to the power 3 into lambda is 550 nano, means 10 raised to minus 9, and h value is 6.63 into 10 raised to minus 34, and c value is 3 into 10 to the power 8. 34 minus 8 minus 34 plus 8, it is 26. Minus 26 will come to the numerator, means plus 26. Plus 26 plus 3 means plus 29. Just subtract here. Plus 29 minus 9, it becomes 10 to the power 20. Now they calculate the remaining thing. The ultimate answer is 3.84 into 10 to the power 21 photons per meter square per second. Photons per meter square per second. Photons emitted on this particular square area, meter square per second. This is our answer. Keep in your mind, if they are asked about the how much energy means, by using the wavelength we can find that energy also, and if you not mention the power also, we can find the energy for each photons. Instead of n number of photons, if I mention the one photons energy, means just to multiply 1 into this values, the each photons emits this much of energy. If the less than this much of energy, it is not possible to eject the electron from this particular flux. Okay, now come to the next question. The next question is question number 7. An experiment on photoelectric effect the slope of the cutoff voltage versus frequency of incident light is found to be how much? 4.12 into 10 to the power minus 15 Vs volt second. Given data is, they mention the given data, E is equal to 1.6 into 10 raised to minus 19 coulomb. If they not mentioned also, you should remember these values. Estimate the values of Planck constant. They mentioned in the bracket, and they asked estimate the value of Planck's constant. Estimate the values of Planck's constant. Okay, this is our question. Listen here, just read yourself clearly what are the things they mention and what we should find from that given data. Listen here, an experiment on a photoelectric effect, the slope of the cutoff voltage versus frequency. Cutoff voltage is nothing but a stopping potential. Stopping potential voltage versus frequency of incident light is found to be this much. That slope is found to be this much volt second. Now estimate the value of Planck constant. Already we know that the Planck constant values we should find from this given data. This is the experiment done. Now we know the value of Planck constant. Before going to know that values, they made a certain experiment. On that particular experiment, this is the incident light is found to be this much. For this much of incident light on a photoelectric effect, the H value is around 6.63 into 10 raised to minus 34. We should find that value. Okay, how to find? What are the things they mentioned? A slope they mentioned, which versus this is frequency versus stopping potential or cutoff potential V. We know that already. If the stopping potential increases, or you just to consider V0, cutoff voltage or stopping potential. If the stopping potential increases or if the voltage increases, stopping potential is also increases, we can find the slope for any values. Why? Because it is increasing. If frequency increases, stopping potential also increases. From mathematics we know that what is mean by slope means dy by dx. Dy by dx, it is nothing but stopping potential by frequency. What is slope? Slope is nothing but dy by dx. Okay, what is the value for the slope? Already they mentioned the slope value is an experiment on a photoelectric effect. The slope of the cutoff voltage versus frequency of incident light is found to be, this is our slope value, how much? 4.12 into 10 raised to minus 15 Vs. And charge value they mentioned, estimate the values of Planck's constant H. Okay, what is the relation between stopping potential and frequency? What is the relation between stopping potential and frequency? We know that the energy is equal to a stopping potential EV0. Energy EV0, we know that already. Energy is our any type of energy, kinetic energy is equal to stopping potential, then only the emission of electrons takes place. Already we know this concept. Similarly, shall I consider here energy is equal to EV0. Now this energy of photon is h nu EV0. Now here we can find h is equal to EV0 by nu. What is this? V0 by nu is nothing but slope. We know that the values and we know that the charge value. Just substitute here. What is E value? 1.6 into 10 raised to minus 19, and slope V0 by frequency nu, that is 4.12 into 10 raised to minus 15. Here is in terms of coulomb, here is volt second, that is nothing but joule second. Coulomb into volt is nothing but a conversion of electron volt to joule. Electron volt to joule, we know that already. EVS, EVS. Here E means charge coulomb. Coulomb volt is nothing but a joule. Joule second is our unit. Now the ultimate answer is just multiply 1.6 into 4.12, that is around 6.3 something. Approximately I am writing here 6.3 something, that is minus 19 minus 15 means 10 raised to minus 34. What is our unit means? Coulomb volt is nothing but a joule, that is joule second. Okay, like this they find the values of Planck's constant. Okay, this is about the today class. In the next class, the numericals they asked in the last year, for example previous year question I am going to solve. This is about the today class. In the next lecture I am going to discuss the previous year questions. Okay, thank you.